So the last thing that we need to talk about now is the final node in our sequence here, and that's the results tab. Here is where we actually take a look at the results and we see what we've been computing for so far. The head node doesn't have so much useful information, to be entirely frank. It's really just a container for the other things. I'll come back to data set in a second. Views and derived values and tables are frankly a little bit advanced for this. We'll see if it comes up in later lessons. So what you're going to do is when you use the model wizard, it actually pre-populates a bunch of these different nodes. Each one of these nodes corresponds to a different figure. Within the figure, you could have lots of different things. You could have a surface plot. You could have contours on top of it. You could have streamlines. You could have all sorts of things. I'll show you some of the different tools that you can use. And if you click on that chevron, you'll see the different components of that. So when you use the model wizard or when you've used the application library, it's kind of already put these in. Otherwise, what you would do is right click on results, and then you select what kind of plot group you want. Think of your plot group as if it was like a figure and you were defining this for a particular project. So you go to temperature, you select the geometry. For example, whatever you want to calculate on, you can specify the temperature. This is pretty self-explanatory. This is for the overall figure, and then underneath it are your actual plots. So here is temperature, right? This is the color bar here. You could say the color table, uniform, gradient. You can choose which color table you want on the right hand by clicking on this little icon over here. There are various options that you can tweak to get what you want. If you click on this head one, say on top of a surface, you also wanted to see, let's do a contour plot. Okay, so now you want to do the contour, you add that because you want it on the same figure. You hit plot, and lo and behold, now it's added contours to this. Let's delete this for clarity, and let's see what arrow plot will give us. So this is a little bit, oh, that's really small. I got to zoom in here. But now what you see is this funny definition. What this is actually the thermal diffusive flux in the R direction. That's how you would read this. Because it's object oriented underneath, you can kind of see the exposed nodal structure to this. Heat transport is the type of physics that we're looking at. D flux R is the diffusive flux in the R direction because we're working in axially symmetric spaces. Okay, so let's delete this again for clarity. The next one, because we're using the model or the model wizard, or in this case the application library, it's already done this for you, which is super sexy, to be honest. When you look at something like this, we're actually solving it in 2 dimensions, but it's 2D axisymmetric. So you can imagine that revolved, or you can actually get COMSOL to do that and actually have it cut out in a particular way. The way you would have to do this is up here under data set, because it doesn't actually have data for 3D. What you would need to do is go in here, right click on your data set, and you need to create a data set. And that creation is Revolution 2D, because we're going to take this surface and revolve it from R00, these are the points, around 2, 0, z is equal to 1. That takes it and revolves it around, not completely, because we don't want to see it completely. And then when we go and we do a volume plot, this is what we get. This is also really nice because now you can do funny things like, for example, let's do an isosurface. Let's do it according to temperature, disable this node so we can see what's going on. I'll click on a different node to plot it. And now you get some really interesting, thank you Windows, some really interesting plots that are actually, it's the same information. All you've done is presented it a different way. And sometimes that can really make the difference between somebody understanding what's going on and not understanding. This is just an isothermal contour. The final thing I just want to show you, actually I'm going to have to show you for the time-dependent parts. You can also create animations here. Thank you, Windows. One more time? No? Okay. You'll also be able to create animations here. There's not much to animate because this is a steady state, but animations are one of the best ways to understand what's happening in a time-dependent solution, because then you can actually see things progress. And I'll show you how to do it, you can export that to, I think it's a AVI file, or I think WMV, or even a sequence of images. So that's all very useful.